Okay, so last week I posted an image of this, or shared an image of this canvas that I've been working on and noodling on. That sort of talks about what just sort of dissects or sort of brings up challenges with the current paradigm of how we build web interfaces, which I'm calling the component paradigm, and what potentially a new paradigm could look like that is um, able to solve some of the challenges that arise with the sort of our de facto paradigm. Um, and I'm calling that the behavioral paradigm. So I figured today I wanted to build off that, but instead of just talking through this diagram, actually like show what I've been thinking about. So instead of talking through this diagram, I'm just going to provide a very short overview of what the differences between the sort of the core um, differences between like how I think about the component paradigm and how I think about the behavioral paradigm that I'm still trying to figure out, and then we'll actually dive into like a demo and build a little thing that a little make a working demo of with this new approach, and hopefully that shows how it's different or how there's different boundaries that emerge. So the core premise or the core framing or lens to think about these paradigms is what my friend Fraser calls the clustering problem. So uh, the clustering problem can be succinctly defined as if you cluster on one thing. So if for example, if we're talking about the component paradigm, if we cluster on uh, the hierarchy of the user interface, then that means that we can't cluster, that we're intentionally not clustering other things. We can't. Um, and that's sort of visualized in this little component tree that you see here, where there's an app and a header and a main section and maybe some kind of drop down and some other sections that exist, right? And the key framing is because we're clustering on the high level hierarchy of the user interface as opposed to the individual elements that make up that hierarchy. Um, and we reason about things through locality of these components. So if there's state or behavior in the header or in the main section or in the select, it should live there. It should there's this like really hyper local thinking that if components are sort of self encapsulated and can do their own thing, right? Like they're sort of autonomous. They have some sort of autonomy. Then you can reason fully about that component without having to know about the rest of the application, which is great. I think there is consensus that there is some merit to the what to what this particular paradigm allows us, how it allows us to reason about the web user interfaces that we're building, and also how to scale them up and how to bring in design systems and stuff like that. But I do think there is an acute problem that particularly happens maybe for most applications, but especially for highly interactive applications, where this particular clustering causes a lot of problems, and those problems can only be solved by this like additive mindset where it's like, oh, now we have all the state at the root of our application instead of it being hyper local because it's used everywhere, and so now we need a state management solution to bolt on to that, and then we need to figure out a way to pass that around the component tree that's encapsulated, so there's no easy way to get that data down, and then the events that components are sort of listening to, that individual components are listening to, like we probably want to send that to the global state management. So you end up with all these problems that arise from this particular clustering that we're doing. And so the premise of the behavioral paradigm is, what if we cluster on behavior instead? What if we make behavior a first class thing? What if we make it easier to create a shearing layer between the view layer, the user interface, and the behavior of our application? Is it easier? And by shearing layer, I mean, like, can we make it so that those things can move at different speeds? Can we make it so maybe we want some behavior coupled to a particular part of the UI, and then maybe at some point we decide that we want it globally, with the behavior to not be coupled? Like, can we more easily enable those kind of interactions? And so the behavioral paradigm that I sort of frame here and get a little bit into the weeds in is sort of rooted in that. How can we more easily reason about the behavior, right? The biggest problem is that with the component paradigm is we can understand a part of the system, and that's great as long as that part is encapsulated. But once a selection or some kind of input, it affects something outside of itself, it has to emit events up the component tree, and then data needs to get passed down, and side effects need to be performed. And so there's no collective whole. There's no way to reason about the behavior of the application as a whole, because it's split apart and decomposed and dissected into all these encapsulated components that all have their own behavior and data. So one, it's hard to understand at scale, and two, over time, more and more data and behavior bubbles up the component tree until you get to the root, because maybe right now our header has some data that it has, that just that only it needs, but then maybe some other part of our application needs that data or behavior, and now we need to hoist it up, pass it down here, and then pass it down to wherever it has to go. And so there's over time, like if you're building out a product or whatever, it's really common that this happens, and over time more and more state and behavior bubbles up the component tree, because of that. And I don't think that's ideal for some. I don't think that's always an ideal trade-off that we want to sort of be stuck in. And then the last point is, in this component paradigm, I think there's this implicit assumption that components are the only thing we can compose on. And so I one of the things I see manifest a lot is we have these design systems are going to export only components, even though if those components could just be like a utility class, or maybe a set of utility classes, or maybe just some behavior, we're sort of rooted in this concept that the only thing we can compose together are components, and that's not really true. There's a lot of different tools and mechanisms that we can compose web user interfaces together, and I think it's in the worst cases it can be really detrimental to design. Like it feels like it's making things so much more complex when we can only think about composing things as components. And I think the other thing to point out here is, I'm not saying that clustering on the user on the user interface, the hierarchy of the user interface is necessarily bad. I do think it's important. I do see value in being able to compose together design systems into almost an infinite number of products or user interfaces and stuff like that. And that form of composition is important, but it's not the only form of composition that we have. So those are some of the challenges and problems I've been thinking about. So let's get into our demo. So right now, I prototyped this little game of Simon. Essentially, it's a very simple game. Essentially, we could turn it on or off, and then if we start playing, it's going to show us a sequence of patterns that we have to remember and then repeat, and then every time you repeat it correctly, another color is added to the sequence, and once you get to a pattern of 20, you win the game. That's pretty much it. So I've taken the liberty of essentially programming the view layer. So we have some HTML here that is what you see on the screen, and then below that there's a bunch of maybe like 200 lines of CSS to style this. It is a little finicky this particular layout is a little finicky to style because of just a lot of absolute positioning, and there's some fun hacks to get these buttons to look like they do. But overall, it's pretty straightforward, I'd say. One thing you can notice is our DOM is very shallow, and very simple, and so we're trying to stay as semantic as possible. I think that's going to be really important here. Yeah, and there's various reasons for that, but you can sort of see if we go to our little console right here. We have our console. We have each of the buttons in the console. We have our header, start button, the display, the strict button, and the on and off switch. That's essentially what this user interface is. And so, in a component oriented way, you'd probably say, okay, we have these buttons here. Let me create a button component, and it's going to take a color prop. And maybe it's going to have some state, whether it's like active or not actively being pressed or not. And we'll have an event listener that listens for clicks. And that's like typically how you would frame that. And then you would have some kind of console, and that's going to have some behavior within, and maybe it'll emit some event when we start or to get turned on or off. And maybe it'll have like a text number that it will take in a prop that's like the number of sequences that we have, right? But ultimately it doesn't care about the sequences. And then the root of our app will contain the behavior of the game, because that makes the most sense here. So we're sort of foregoing that, right? There's no componentry. We have just a very flat DOM here, hopefully semantic DOM here that sort of articulates everything that we need. And we also have a custom element that is wrapping our game. And this is going to be important when we actually start defining behavior and getting into the nitty gritty. But for now, I'll hold off on that. The only peculiar things about how this is implemented, and let me make this a little bigger, is all of the conditional rendering happens in CSS. And the goal of this of like what I've been exploring is maybe we don't need a declarative templating system to render everything. If we can project some state of our application into the DOM via attributes, we can use that state to conditionally style things. So for example, if we turn, our game of Simon has a mode, and maybe we could turn it on, for example. And you could see that when that happens, the screen turns on. And all we're doing here is just this little style right here, which says if our game of Simon is in mode off, then set the color of the I guess I don't even need this. Let's simplify things. It's saying if our game is off, then the color of our game of the display should be translucent. There shouldn't be any color, and we could add a little animation that fades the screen on and off. So let's turn our game on. Yeah, and you can see the same thing happens. Cool. Yeah. So all of the conditional styling of this game happens in that way, which is pretty cool. And then another example of some like conditional styling is the strict button. If our game assignment is in strict mode, so we just had a strict attribute, you can see that it turns on, and that's essentially what this is doing. We have some additional logic that says if our game is in strict mode and it's not off, then we want to display the button should display. So if we do change our game to off, you can see that the button also turns off or fades out when the game is off. So we can use some very, I would say, relatively simple conditional styling to do this. And what it avoids is we don't have to declaratively template things. That means if we're server rendering, we don't have to hydrate things. We don't need to learn whatever templating system and DSL that are out there, whether it's JSX or using tag template literals. And I think a majority of rendering, whether it's like if this is true, render this, else render this, or conditional attributes like if this is true, then add this class. A lot of that can be significantly simplified, and we don't even need any JavaScript in order to represent that. And so we could have a fully functioning user interface by just changing some attributes of the DOM, which also makes it a lot easier to debug. That's like a big emphasis, is like how can we use the dev tools that are built into every browser in order to debug and understand what's happening better. And so if you create a user interface in this way, you can have a highly interactive, ideally, you can encode a lot of the interaction and conditionality of a user interface just into CSS. And what's also cool is CSS has become so much more powerful in the past a couple of years with things like the has selector and query containers and everything like that. It's a lot easier and a lot more expressive to and a lot simpler to write these kinds of CSS styles and still understand them. So I think that's a big point of emphasis here. So yeah, that's sort of what I've implemented so far, and sort of diving into like how things are styled. And yeah, the DOM being shallow and stable is going to be really important here. And you could see using like slots, like not in the sense that they're usually used in with like the shadow DOM and stuff, but just we could semantically label parts of our user interface. It doesn't matter what the structure is. It's just this is our console, right? And we could use this attribute to style things instead of having to find a section and then find the label below that. So we could also define some like more context and meaning to the DOM that we're writing and querying that, whether that's in CSS or JavaScript. So that's the first part. The second part, and I think this is really important, is in the component paradigm, because you have this like hyper locality, you want to encapsulate things inside of a component, and you have these declarative templating systems. What always happens is you're directly attaching event listeners to elements, or at least that could be an implementation detail, but conceptually you're saying, hey, when let me add, like, if this was like JSX or whatever, you'd have your little on click, and then you'd pass a call back directly to it, right? Um, that causes a couple problems, especially when you're trying to create a sharing layer between the behavior of your application and um, the UI layer or the view layer, because you have to pass down. Essentially, the templating system is letting you attach things without an explicit reference. It's like more of an implicit reference to that element, so that you could attach an event listener to it, and then that, like, when this element is clicked, that should do something. So really what that means is there's this implicit intention that exists, where it's not the click event on a certain button that is meaningful to how we process things. We know in our heads that when this blue button is clicked, or when this toggle is clicked, then something should turn on, right? And what I suppose here is we should be more explicit with the intention of events, and that enables some really interesting boundaries and patterns that I don't really see a lot, especially in a browser where it has this wonderful thing called event bubbling. And what I mean by that, let's go to our start button, for example. If our start button is clicked, what the browser does is it says, hey, is there a click handler on this button? If there isn't, then it's gonna bubble up to the section. It's gonna say, is there a click of a handler on this button? If not, it's gonna keep bubbling up the DOM all the way into the window. So we could use this pattern called event delegation, which says, don't attach event listeners directly to the elements that they're on. We can let those events bubble up and then do something with them. So now we can decouple the upward flow of events that is emerging out of the view layer from having to directly reference and attach event listeners to certain spots. And so that leaves us with two ways to handle these delegated events. And there's a reason that we're using custom elements. Part of that is to delegate events, as you see here. So for example, all the events that we're going to generate in this particular user interface are going to be handled by our game assignment. And one of the benefits of that is now we have a centralized place where we're responding to events. And if we have a centralized place that we could respond to events, we could use whatever behavioral notation that we want to do that. So it could be a switch statement, it could be a reducer, or like Redux, it could be a state machine, state chart, it could be a behavior tree. There's all these different behavioral notations that we have available to us that we could easily swap in and out in order to respond to define behavior and then respond to the events coming out of the user interface. Again, so there's two ways to handle, or there's probably more, but I think there's two. The main way that usually event delegation works is maybe we get an event that emerges from our start button, right? And then we have to sort of query the DOM to say, hey, what was pressed? We need to figure out what the intention of this click event was. And if you're not tightly co-locating those event handlers with the elements that they're supposed to, that could become really complicated, and also couple you to the structure of the DOM. So the alternative pattern that I sort of propose here is this pattern called intentions. And so essentially we could declaratively map the intention of the raw browser or computer event that is coming out of that is stemming from some interaction, and we can map it to something meaningful. So here we can sort of see like when the start button is pressed, we can add, we can map, we can say, we can declaratively say, hey, when this button is clicked, that what that actually means is start game. Now we want to start the game, and you can also do that for everything else here. So we can also say on click, we can say toggle strict mode. Right. So when you click this, click the strict button, that's going to toggle strict mode. We can say when this on input, so whenever this checkbox is clicked or toggled, we can say toggle power. Right. So we're going to turn off or on the switch. And then for these buttons, they're actually all going to have the same intention, right? So let's mass edit these. So when these buttons are clicked, what that actually means is that the a color was pressed. And then because we have the color here, color red, we can actually use that as a parameter to these intentions, right? So that those are the interactions of our game, or those are the intentions or events that we care about. And what's important is, and I would argue, we don't care where they come from, as long as they bubble up. That's what's important. And what that means, a couple things. You could have the same intention in multiple parts of a user interface, and I think this is probably pretty common when you get when you have highly interactive web user interfaces. There's typically multiple ways to generate the same intention, and maybe that could be a key press, right? So maybe a key press does the same thing as a mouse click on a certain element, or maybe there's just two ways to close out of something. Those all under the hood mean the same intention. And we don't really explicitly describe that. And so this pattern here says if we explicitly map the intentions in the DOM, we could actually start figuring out the behavior of this user interface by just looking at the outputted HTML or our source code. We don't have to dive, so you can sort of get a high level overview of like the behavior that's emerging out of this user interface. We can decouple the events that are coming out of this user interface from the behavior that's receiving them, because it could technically be received anywhere. There's a composability mechanism to this. If you use custom elements, which are part of the DOM and take part of this bubbling, they can stop events from being propagated, emit their own events, or they could just let a certain event flow through if it's not meaningful to them, and something else can receive it. So there's this flexibility here that I think is really important, and I think this is the crux of what a behavioral paradigm could look like in some form or another. So it's been about 30 minutes. I don't want to keep this video for too long, but let's actually like implement these intentions, and then maybe in the next video we'll implement the actual behavior of the game. So what you see here is a custom element. I have a little helper that essentially just does the event delegation for us. Which is pretty cool, and it centralizes this in this handle event method. In which case, so every event that we're delegating is going to get is going to call this method, and then we can describe the events that we're delegating Maybe in the future this could be like an attribute on a component and on this component instead. I think there's still some things to explore here, but the two events that we're delegating are click events and input events. And to show that it's working, let's console.log the intentions from when we click. And then I also am bringing in this 5-line helper that is essentially finding the closest intention from where the event's coming from. So one of the things that means is if we have a nested, like a nested DOM, like the start button, if the start is clicked, then is the thing that's clicked. What this helper is going to actually end up finding the intention start game here, for example. So just there's some flexibility in terms of that, as well as it's not like the button has to be directly clicked. Anything below it, which is pretty common in the component paradigm too, because that's sort of how event handlers work. So let's go to our console. I mean, we could stay here and press escape and open up our console. And then let's see what happens. Let me save. So let's see. So you can see toggle the power, start the game, toggle strict mode, color pressed. So those are all the events that come, or intentions that come into our game, and now we have a central handler in order to actually like respond to those. Which is pretty cool. And yeah, for right now, I'm gonna leave it there. And in part 2, we'll actually implement the behavior of this game. Now that we sort of have the user interface down, the user interface is pretty much done. So yeah, I'll leave it off there. Thanks for watching. Tune in for the next one.